Welcome to solverfy.
In this problem, we're asked to show that the polar radius of gyration of the annular area shown is approximately equal to the mean radius, which is r1 plus r2 over 2, for small values of the thickness, which is the difference in r2 and r1. So then we want to determine the percentage error introduced by using the mean radius in place of k naught, or the polar radius of gyration, for three different values of the ratio t divided by rm. Okay, so what we need to do here is we can calculate our polar radius of gyration from the previous problem, because we know the area of the annulus and we know the polar second area moment. So we get the polar radius of gyration. And then we can introduce that r2 is r1 plus t, because we're going to say that t is a small parameter, so for small values of t. And so we've introduced our small parameter here, and because of that we can then use the Taylor series to get kr approximate. I use the tilde for approximation. And if we just get a first order Taylor series, that's kr evaluated at t equals 0, plus the derivative of kr with respect to t evaluated at t equals 0 times t. And if we do if we take the derivatives and do everything else, and then substitute back our expression for that t equals r2 minus r1, we wind up with this approximation is indeed r1 plus r2 all over 2. Now, we know we can get r1 and r2 in terms of the mean radius and the thickness, okay? And we can then we can calculate this expression here, kr over rm. Okay, so we have kr here. We can divide it by rm, and using these relationships we can get r1 and r2 in terms of the mean radius and the thickness. And after some algebra, we wind up with this ratio here is square root of 4 plus t over rm squared all over 2. And so we want to calculate the error. So the error is going to be kr minus k tilde all over, or kr minus rm all over kr. And so we get that is 1 minus the inverse of this ratio times 100%. We can then plug in t over rm is 1, and our error becomes 10.55%, which isn't too bad, because this basically is saying that thickness is considerably large, is basically very large compared to their mean radius. In fact, it is the mean radius. So that wouldn't really be t equals a small number. So we wouldn't expect a very good approximation, but it's not too bad. For t over rm equals 1/2, again, this is kind of small, but not that small. We get an error of about 3%, which is pretty good for not a very small thickness. And for the thickness is 1/10 of the mean radius, we get an error of 0.125%, and we can see that that's pretty good, because now we have a small thickness compared to the mean radius, so we're getting a very small error in our approximation.